In this lecture, we discuss about Robbie's test. Let sum of un be the series of positive terms such that limit of n times of un upon un plus 1 minus 1, which is equal to L, then the series sum of un is convergent if L is greater than 1, is divergent if L is less than 1, and test fails if L is equal to 1. This is called Robbie's test. This test is applied if the ratio test fails. Let us explain this test by taking one very good example. Let us test the convergence of the series 1 plus 1 upon 2 plus 1 into 3 upon 2 into 4 plus 1 into 3 into 5 upon 2 into 4 into 6 and so on. The given series is sum of un is equal to 1 plus 1 by 2 plus 1 into 3 upon 2 into 4 plus 1 into 3 into 5 upon 2 into 4 into 6 and so on. Here, nth term un is given by, just look here, this is the first term, or we can leave the first term, this is the first term, then second term, third term. Similarly, if we take the nth term, what we can write down? 1 into 3 into 5 into, what is nth term of the 1, 3, 5? So 1 plus 3 plus 5, if we take like this. So first term a equal to 1. Common difference d equal to 3 minus 1 is equal to 2. So Tn is equal to a plus n minus 1 d. A is equal to 1 and d is equal to 2. It gives us 1 plus 2n minus 2, which is equal to 2n minus 1. So it is written over here up to 2n. Nth term will be 2n minus 1. Similarly, here the first term is 2, second term is 4, third term is 6. So nth term will be 2 times of n. So nth term of the given series is this. Now, we want to find out the n plus 1th term, which is nothing but we have to add one more term, n plus 1 terms, by replacing this n by n plus 1. And similarly here, the another term, n plus 1 terms, which is 2, n is replaced by n plus 1. So if we simplify it, 1 into 3 into 5 up to 2n, and this term is nothing but un. And if we simplify this one, is 2n plus 1 divided by 2n plus 2. And this is un. This is un upon u. Now we have to consider that what is the ratio of un upon un plus 1 when n tending to infinity. Here un is un and un plus 1 is 2n plus 1 upon 2n plus 2 un. So un will cancel. And this 2n plus 2 goes to numerator, 2n plus and 2n plus 1 comes to denominator. If we take n outside, then n will cancel. If we put the limit 2 upon infinity is 0, 1 upon infinity is 0. So we are getting 2 by 2, which is equal to 1. Since the ratio of un up and un plus 1 when n tending to infinity is 1, so hence by Robbie's test, ratio test, the test fails. Now, since the ratio test fails, so we use, hence ratio test fails. Now, we have to check the convergence of the given series by using Robbie's test. Consider, so what is the expression for Robbie's test? The value of L is nothing but n times of un upon un plus 1 minus 1. Here, un upon un plus 1 is nothing but 2n plus 2 upon 2n plus 1. If we simplify it, The LCM is 2n plus 1. So 2n plus 2. And this minus 1 multiplied with 2n plus 1. So minus 2n minus n. Minus 2n plus 2n will cancel. This 2 minus 1 is equal to 1. This n into 1 upon 2n plus 1. And if we take n outside from 2n plus 1, it is nothing but 2 plus 1 upon n. So this n will cancel. And we have 1 upon 2, which is less than 1. So since the limit n times of un upon un plus 1 minus 1, when n tending to infinity, is 1 by 2, which is less than 1. Hence, by Robbie's test, the given series is divergent. Thank you.